San Clemente Island is the southernmost channel island located approximately 70 miles west off the Southern California coast. It was selected as the testing site because of the clear deep water and the relatively low levels of ocean background noise. For transport of whales to and from the home base in San Diego Bay, we employed the research vessel Acoustic Explorer. Here the vessel arrives at daybreak off San Clemente Island to deliver our 2 whales. Each whale has been resting in a fleece-lined stretcher suspended in water in its transport container for the 8-hour trip. Veterinarians and trainers have been monitoring their physiology. Within a few minutes after release into the water of the pen enclosure, Muktuk approaches the trainer for fish. Within a few days, both animals were eating well and adapting to their new home. Muktuk is signaled to leave her enclosure to boat follow to the work site. At first, she was reluctant to leave the immediate area around her enclosure, often breaking away from the boat to return home. When she was at the work site, she appeared anxious and very often refused the signal to dive. At the point she accepted the signal to dive, the time on the bite plate was slowly increased. As she acclimated to the immediate area, she began to focus on the trainer and the task. Although she had minimal problems progressing to multiple dives upon reaching 100 meters, she stopped responding to the acoustical tones. Although we could not be certain she could hear the tones at 100 meters, we decided to approach the problem as a behavioral breakdown. We regressed back to working her on the surface and giving her 1 tone at a time, set at a frequency and amplitude that she could hear. Her vocal response was reestablished and she steadily progressed towards completing the chain of behaviors required to collect data. Nosy progressed very quickly, working out to 1 mile offshore, making multiple dives to 75 meters and responding loudly to audible tones. However, once he had progressed to multiple dives at 100 meters, his attitude began to deteriorate. He was slow to station for a dive and on occasion would leave the worksite to return to his enclosure. He began to refuse the acoustical recall, and keeping him under control, boat following to the worksite became increasingly more difficult. One particular avoidance behavior we called mucking had delayed several training sessions. Nosy's obsession for mucking at inauspicious times had given us problems in the past. The behavior appears to be intrinsically rewarding and therefore difficult, if not impossible, to extinguish, especially in the open ocean environment. It appeared obvious that the breakdown in the chain of behaviors was due to Nosy's adversity to making multiple dives to 100 meters. Our approach was to segregate the problem behavior from the chain. We regressed back to 75-meter dives and worked on his motivation by using a variety of positive techniques. These included keeping the session short, boat following between dives to break up the work session, and keeping the number and length of dive times random. When his motivation increased, we integrated a single 100-meter dive into a session and progressively added additional 100-meter dives as he improved. Collecting data at 5 meters and 100 meters was completed at the end of December of 1994, and the whales were returned to San Diego Bay to prepare for the second phase. Six months later, in June of 1995, we returned with the whales to San Clemente Island. The day following transport, we were again diving both whales to 100 meters. Muktuk progressed quickly, including a clear vocal response to multiple tones. Nosy, on the other hand, became increasingly stubborn, refusing multiple dives upon reaching the 100-meter depth. Attempts to improve his attitude continued to fail. Techniques used during the first phase were successful up to 75 meters, but once diving to 100 meters, he balked at preceding signals. Achieving the 200-meter depth was beginning to appear impossible. On one particular occasion, Nosy refused to go out to the worksite or back into his enclosure. This put the workday at a standstill. Time was of the essence, and we had to come up with a solution. There had to be a better way.
He wasn't happy with it. I heard him making the mess.
Even though both whales had been conditioned to swim along on the left side of the inflatable boat, Nosy had no problem following along the right side. He was conditioned to drop under the boat and move to the left side when the engine was slowed down. This enabled the boat driver to tie up along the right side of the work site. One whale was given the dive signal and the other whale remained on the surface. Working both whales at the same session gave us an advantage. Initially, we were reluctant to let Muktuk out while Nosy was not under control because of the possibility he would interfere with her session. We didn't need any additional problems to solve with the time constraints of the project, and such a procedure had not been attempted in the past. Therefore, developing a precise conditioning strategy to meet our needs would be crucial. We hoped it would enable us to work through Nosy's attitude problems in a unique way. We surmised that competition between the two whales could improve his motivation. If he refused the dive signal, we could send Muktuk down for the dive when she appeared ready. It would save time continuing on with the session instead of returning Nosy to his enclosure. Also, by boat following them together, time to the work site would be cut by half. Utilizing the surface interval time for one whale while collecting data on the other whale enabled us to make up the time lost dealing with the predictable as well as unpredictable problems. Once they began working together, both animals appeared more relaxed and most of the problems were resolved. Problems we had with Nosy's disruptive mucking ceased. The whales were allowed free access to the area outside their enclosures and spent many hours swimming and mucking in the area before and after daily work sessions. Nosy's attitude improved dramatically. Progression went quickly and the remaining data was collected. Initially, we felt that the improved performance of both whales was due to competition between the two animals. However, after observing both animals for some time, it appeared to be cooperative. Perhaps due to the ever-changing conditions the whales encountered, the advantage of numbers needed for safety and protection was an important factor. Unpredictable problems were encountered on several occasions. Indigenous wildlife, such as large herds of common dolphins, pods of rhesus dolphins, sea lions, and sharks were encountered on a daily basis. We decided to minimize shark encounters by leaving the work site at the first sight of a shark. At times, poor weather conditions made working difficult or impossible. Condition of the enclosures were constantly checked for structural integrity. At bi-weekly intervals, after completion of a series of dives for hearing threshold tests, the whales offered their flukes for blood sampling by veterinarians. The blood samples were then rapidly processed for storage and transport to laboratories concerned with high-pressure physiology, performance, and circulatory adaptation. Late in December of 1995, we returned home to San Diego with the whales successfully completing the project Deep Here. The following narration describes the results.
Here, we have presented the first ever controlled tests of hearing by any marine mammal in the open sea. Trained white whales made 885 dives to a submerged test platform at 5, 100, 200, and 300 meters in the Pacific Ocean. Whales stationed on the platform for 4 to 12 minutes at a time and made a sonic response, whistled or squealed, when a 500 millisecond tone was presented via a hydrophone 2 meters from the lower jaw. The sonic responses, which whales produced by pressurizing air in the nasal cavity, increased in peak spectral frequency, and decreased in amplitude from 5 meters to depths of 300 meters. However, audiograms were not significantly different from 5 meters to 300 meters at 8 frequencies: 500 Hz, 2, 4, 8, 16, 24, 64, and 100 kilohertz in one whale, and at 5 meters, 100 meters, and 200 meters in the other. Air density increase in the middle ear, sinuses, and nasal cavity, an increase that must occur at static pressures up to 30 atmospheres, markedly changed the whale's sonic response but did not attenuate hearing overall or shift thresholds at different frequencies, as it does in the aerial ear of humans and other land mammals tested, due to middle ear impedance changes. The findings support theories that sound is conducted through whale body tissues to the inner ear without the eardrum ossicular chain transduction of the aerial middle ear.
As trainers, we have learned a great deal from this experience. We understand that while it's not uncommon for animals to cross paths while going to and from work sites, taking this opportunity to work animals on the same task and maintaining control for the purpose of obtaining research data or other work-related tasks requiring cooperation adds another dimension to our jobs, with greater opportunity for using new techniques to meet the challenges of working in the open and unrestricted environment.